deep,
The deck is
200 deep deck for a big span. Small span, 45 deep deck. 5 metre span, 100 deep deck. So depends what the spans are and the depth of the deck and thickness of steel, 0.7 to 1.5. So that's your typical deck construction. So you've got the variable control layer, the clips. The clips are set out in a diagonal orientation, so the external loads are spread evenly onto the deck profiles. Insulation thickness for U-value performance, and top sheet to suit the project specification. So these are load considerations. The calcium outer sheet accommodates external loads which are transferred through the clips into the structural deck. So the calcium outer sheet accommodates wind suction or pressure, any imposed loads. It says snow there, which appreciate you don't get much snow in this region. So that'll be maybe sand. Access walkability. We have different low span tables because we do two types of halter clips. So there's a slight difference in the structural performance. And another consideration is the fasteners into the structural deck, because if the deck is quite thin, then we have to make sure the fasteners function correctly in terms of wind suction. So liner deck roof system again is a steel trapezoidal profile, but this has some structural capacity. And we do 3 liner deck profiles, 35, 32 and 46. And depending on what the depth is, we can achieve greater spans. Also has a top hat spacer system in there, so we can increase the build up and achieve better U-value performance.
So you put this additional support only if you want to make the composition bigger. Only.
That's right. And also, there's another slide coming on, but in this space we can also put this intermediately as well. So sometimes where the wind loads are higher around the perimeter of the building, the deck is fine, that'll span, but maybe the calcium outer sheet won't span, so we put an intermediate span breaker, which this is a top hat section, a mega section, just fix mid-span. So that's got a bit of flexibility, that system. This is a mega. Yes. Well, the liner is not modular with the calcium outer sheet. So okay. So the spacer then.
If you are supplying the liner, you are supplying the.
Yes. Yeah. We can supply. Sorry.
How it comes not modular.
Yeah.
Because you are designing both.
Because the way the system works, it achieves better U-value performance, so we introduce a top hat section, a mega section. This profile, due to the geometry of the profile and the structural capacity, isn't modular with the calcium outer sheets. Okay, so it's slightly different than the liner system, which is modular. So we introduce the top hat so we can install the clips to pick up the standing seam. So it's a flexible system for achieving thermal performance by increasing the insulation depth.
In case, for example, you have some paper sheet.
Paper sheet.
Usually, it's not all the time. For example, you're going for a thicker profile that is not coming exactly 200 or every bottom. Or we use 200 down and we were obliged to use 333. If we want to make the system to give it more not rigidity, if we want to give more thickness for you, like when we reach, let's say our longest clip 190, we want to lift more, so we have one for that. And one slide will come when we put the top hat in the middle, that's what I explained. That one would be to give the strong rigidity for the top sheet, so it will not fall. So those are the comments.
Regarding the furnace, you'll be having some deflection normally. What deflection is acceptable for your system?
L over 200. L over 200. L, the span, over 200
Over 200.
for dead imposed loads. Wind suction, L over 90. So wind suction, we can have more deflection.
Easy measurement on site, more than 20 mm difference from that's common. You could measure 20 mm. If more, you can tell the steel people by applying for your
It's short. In this direction, it's not very critical because sheep are almost independent, right?
Lateral move.
Yes.
Yeah. This direction here, L over 200 between purling spans. So
So in the
Yeah.
measure direction,
Yeah.
L over 200.
Yeah.
This and along with the furlongs, not necessary.
that's right.
Excellent.
Okay. So the cowslip outer sheet is fixed to the clips. The clips are fixed to the top hat, and the top hat is fixed to the structural liner deck. The loads, the cowslip sheet accommodates the wind suction loads or any pressures, imposed loads, access, walkability. Again, load span tables, we look at the load span tables, compare the span and the cowslip profile to determine the centres. Again, we also look at the fasteners into the top hat, into the structural liner deck. So there's your slide we explained before. So this could be maybe 2-3 metre centres between these purlins. So which is that span, 3 metre span, maybe too great for the cowslip sheet. So we can introduce this intermediate span breaker. So the deck is okay structurally. This top pattern is to accommodate the cowslip outer sheet. So this could be around the edge of the building where you need to put the supports at closer centres. Then when you go inboard where the loads reduce, you can maybe emit. Sorry? This just riveted or self-drill fastener to the sheet. Okay. Only for the liner, only for that system, the liner deck system. So we don't have to always use top hats. No. Structural deck system, we can fix the top hat, the clips directly to the crown of the deck. So these are all, we've got a lot of flexibility with what we can supply for various different solutions. So this is an example of the acoustic type of build-up. We can offer different products, insulation, which will have different mass, acoustic board, again like cementitious board, to add mass. We have acoustic membranes, which are in rolls, and they roll out on site, again 2 millimetre thick or 4 millimetre thick, again to add mass. So we add mass to the system so we can reduce the airborne noise. That could be noise coming into the building or noise going out of the building. We can also perforate the trapezoidal profiles for sound absorption. And the anti-drumming membrane is used in a lot of schools. It's bonded to the underside of the cowslip sheet, so it reduces the impact noise of the rain when it hits a metal sheet. So we can accommodate sound reduction by adding mass to the system. And with sound reduction, the higher the RW, the higher the figure, the better the sound reduction. Okay. And we have design tools internally where we can predict the sound reduction performance, and it'll give you the octave band frequencies on the software. This is for sound absorption. So here we can perforate the liners. This is in a swimming pool. So normally you'd expect a swimming pool specification to have sound absorption performance. So with cowslip we perforate the liners or the decks to achieve some sound absorption. You can see there, this is a perforated liner, so it's trough perforated, so the sound waves come through the holes in the deck and they get absorbed by this acoustic slab. Okay. These are the options we can achieve in terms of the acoustic performance. The sound absorption coefficients are here, this figure, 0.65, the Class C absorber. We can offer different components to, again, to get a 0.75 sound absorption coefficient. You can see there, with no perforations or any acoustic slab, it absorbs very little. So by introducing the perforations, we're getting some quite good sound absorption performance.
So the acoustic sound, how to be fixed on the profile and how the hunter will be fixed on this that is top.
Yeah, this is a top hat section, Amiga section. Yeah, so normally the acoustic slab would be 30 millimeters deep, so the Amiga section would be 30 millimeters deep, and the clips fixed. Okay. And the vapor control layer sits on top of the acoustic slab. This is a system we've introduced maybe 10 years ago. It's a hybrid system to achieve low U value performance. You see U values down to 0.1. I think normally U values in this region you're looking maybe 0.18 sort of U value. So it's a hybrid, it's a mix of PIR board and glass fibre insulation. So it's very, very energy efficient and reducing your carbon emissions. We have design tools again, so we can work out different U value performance by mixing, matching this thickness of insulation and this thickness of insulation, so we can look for the optimum performance. So that's your typical type of isometric construction. You've got your support substrate, trapezoidal deck, PIR insulation board. This is a load spreading channel, so we don't put too much load onto the PIR board. Hybrid, the glass fibre, mineral fibre insulation, and Calzip top sheet. This is our three-dimensional XT freeform sheets, complex geometry, so we can achieve quite complex shapes. So it allows architects greater design flexibility. We can mix and match the XT sheets with the standard Calzip profiles, again, for cost benefits, so you can optimise the performance of the system. Usually it'll be installed on a structural deck. The structural deck gives us greater flexibility for fixing the clips in any orientation, any position.
Just a question, is flexibility only Calzip is able to provide it, or can you still mix things?
Only Calzip.
He'll not reply.
Eh? That's why I'm here. So you can,
started our XT sheets since 2006, so 13 years back. Some competitors may be trying to follow. Basically.
try.
Because it's a full design. It's not only you get the roll forming design and build, and you get the sheets. We have seen some competition trying to do it, but all follows underneath. We do design the full system that will allow this sheet to work properly. You can get from your computer a beautiful top sheet, but if you don't design what you put underneath properly, the aluminium is very flexible. So while fixing it on site, design intent, for example, is a curve, then going down and curving again. I have seen one of the projects. You see it coming, stopping, and continuing. Why? The sheet is done nicely, but what is under it was wrong. So it's a full learning process that you need to do. It's not by buying or developing a 3D machine that you are really having that 3D capacity. All what is underneath is as essential as the sheet itself.
As the Calzip policy, you are only doing supply or only system for supply and installation?
We have, it will come in our presentation, the training for the
We can,
installers.
we-
In your presentation, are you putting something related to installers and the training process we did?
we can, well, we'll talk about that on the next, just the next slide.
Usually, we train our installer and we insist on specific approved installer. Only training or under those supervision? approved installer. That once they are approved installer, we design the drawings and make sure from time to time to do site visits and make sure, and at the end of the project, we again inspect it, and what we see need to be done on the site should be done by the installer before we issue our warranty to the.
Your training, how much is the budget for the trainer?
There is actually a module of training.
Yes.
Sorry to interrupt. We have something called general operator training. It's a 5 days training, 4 days training, and we recommend that 1/3 of the employees should take this training so they can teach their colleague on site during the training. So we choose mainly people who already work in the roofing industry, not someone coming new. So somebody who started working in the roofing industry, installed some sandwich panel before, or anything related to cladding, and from there they can start doing the standing seam. Most of, standing seam market is not big. You see some supervisor moving from one company to another. So it's a knowledge that can be transferred from one company to another. We assess the team as it is, and accordingly we will decide that whether they can be really an approved calcium installer.
Also, we use Rhinoceros software, which is a surface modeler. A lot of architects use the same software, so we collaborate with the architects to work out the optimum performance, and then with the installation partners, if they have the Rhinoceros software as well, we can share the models, share the information, and we come up with the best solution to achieve the geometry. So there's a lot of support goes through the process with the complex geometry schemes. And as Tony said there, we can visit site when you're doing the installation to make sure you're understanding how the system goes together, where the clips go. So we,
This is I can see like on the photo, punching
Yeah.
here.
here,
Is it like two standing seam sheets sliding above each other?
no, this here, again, this is because we looked to optimise, offer the best solution. This element, this is Aintree grandstand for where they do the Grand National in the United Kingdom. This is XT sheets going over the top of the grandstand. It's like a barrel, so they went wide and curved. They went wide in the middle, curved round and thin at the other end. So this is where we welded to straight sheets. Yeah, so these are just straight standard sheets. This is where it is welded. So the curved geometry.
Joint is welding joint.
Welded lap joint.
Not close.
No, just weld. Continuous sheet, one sheet welded to the other sheet.
I assume the weld is the 6 point, right?
We can put the fixed point, yeah, to control the thermal movement, yeah.
So in principle, you don't have any dropping joints on the system, all welded. So you have joint sheet to sheet has to be welded, right? Or could be plotted.
We do a step detail, so the step detail was one sheet slightly above the other, so they're separate and one can move independently of the other sheet. That's one way of achieving, or we can weld them together. Sometimes, depending on what the roof pitch is, if it's quite a steep roof pitch, we can just lap the sheets with and rivet them together with a mastic strip between the sheets. So different options we can achieve. Okay, any more questions? Carry on. So why aluminium? So we produce our sheets out of aluminium. It's the most flexible materials for building envelopes. It's one of the most common metals in the world. There's a lot of availability of bauxite, which the aluminium is extracted from. It's highly resistant to corrosion, seawater, so it's good in marine atmospheres. Non-combustible, so it's A1 in terms of fire performance. Recyclable without any quality loss. It's light yet strong. Easily formed and worked, you can see by the complex geometry shapes we can achieve. And depending on what alloy you're using, you can enhance the mechanical properties. Non-combustible, doesn't set on fire. Aluminium A1.
Normally the
Yeah, the alloy.
Make it non-combustible.
Aluminium. What? Aluminium, pure aluminium.
Aluminum is limited combustible. Can.
It won't. It may melt. May melt. It doesn't. It,
Can raise the fire.
no, not aluminium. Not our aluminium. Well,
Pure aluminum.
it's not a composite panel. It, so it's just single skin of aluminium. It won't set on fire.
Your system is basically all your system is temperature.
Yes. If it's ACM panel, if it's ACM, the ACM filler will burn, but the aluminium won't burn. If that's what you mean. But our 3000 series,
Per IPC, aluminum and wood are classified as limited combustible.
A
Unless if you treat them specially to make them to upgrade them to non-combustible.
what's that? Okay, but
Your system approve IPCB. PCB approval, we have actually the FM, which is class A rule. Because we are not a local manufacturer, we can have something called certificate of conformity for civil defense, and that's what we have done. So based on the FM approval,
Okay for building.
The ADM works registered, you are one of the companies there registered or not?
in civil defense, actually, they register local factories only. So the register will be for local factories. Since we have FM approval, we are one of the foreign factories that can take the certificate of conformity. So COC, and that's it.
But you will not get a certificate from its civil defense based on your FM certificate.
If you want a registration number, you cannot get. If you want certificate of conformity, you can get. So it depends on what you.
ADM during the construction, you will come visit the site and you will ask the company who's supplying to you to verify it in their system.
Yes.
It is registered there. No, you are not registered there. I cannot purchase as a contractor from you the material. How you are solving this problem?
We have a project now in airport, no problem.
Airport is the airside, it's not under.
Under the
We have many projects based on the FM approval and certificate of conformity. Being a foreign manufacturer, we are getting approved.
Airside, airport side is not under ADM authority. It's under regulation authority. When you are doing outside of it, under the ADM, they're having a regular inspection.
Okay.
So they're asking for the view of the material on supplying, and they'll go and verify it in their system.
simple meeting the requirement of the civil defense. You have the letter, yeah, the letter is the COC. But what is asking how to bridge the gap between to prove the DM that you are constructing.
That we usually give the submitter, and contractor will submit that to the municipality based on the COC, they will give it. That, until now, we never faced no, because we don't have the number, we cannot continue. We have several.
It is in your regulation actually. They are asking for the certificate from civil defense for the material. So you should have the certificate.
Which is the certificate from our side, we give certificate
No, not
of
from you.
conformity.
You should register as Mr. Zakaria said in the civil defense and got the civil defense
Your
approval.
system has to be approved from the civil defense, the complete system in detail, what the panel, sheet, insulation, this is the review of what can be handled here. For example, now one of the projects, there is a condition that this material to be approved by us. Once to remove this condition, I need to know your company provide your material, and the ADM, he will give you the approval based, you are having registration there. He check the system, you are not registration where you don't have from central lab, from the authority, from the vice central lab, if you don't having this verification, this test done, he will not be approved with this. In Dubai, sure, in Dubai, sure, which is under ADM, under DM, Dubai municipality. They don't allow the people.
Abu Dhabi for civil defense is
Why not the middle? Both. The matter is to take your material, example, with your Amazon sheet and approach civil defense for approving your system as your material.
We already approached them, and they separate between two different local companies, foreign companies.
Correct.
Local factory will get the number, you will give it to the DM, they immediately approve. What we do submittal, we will put FM approval, COC, which is signed by FM as the format of the civil defense, and we will give it as a submittal. They will process it and approve. The only difference that this one is immediate, this one is submittal is needed along with other submittal.
But how will you select your name from being system if you are not registered? To prove your U value, you need to select your material from the
Okay. For the
registered
U value,
value.
usually you give the DM approval of the rock tool, not
The installation material.
the installation. We will put it as a tool.
You procure it locally.
Yeah, rock wool will be either Fujairah rock wool or Saudi rock wool, and
Which is
those
already designed.
exactly. If you look at the specification, mainly they put DCD is a must for the rock wool, and the full system should be FM approved, which is something equivalent.
Okay, carry on. These are the alloys we supply. 3000 series aluminium with an element of different alloys to give it different performance. This figure is a clad material, so it has a sacrificial layer, so it gives it extended durability and lifespan. So the sacrificial layer will, as it sacrifices itself, so the pure aluminium below is not compromised. This is a recycled material, so it's environmentally friendly process. We also do different surface finishes. We do the aluminium with a zinc cladding, so it's got a zinc appearance. We do a weathered finish called patina, and we also do patina colours in different colour variations. So we do a patina colour in bronze and the patina colour in champagne. We can also offer painted materials. Again, there's the alloys we use for the painted material. We can offer a variety of different paint applications. With polyester, 20 microns thick, good appearance, good durability. That's common. We offer abrasive resistant paint systems. Again, so subject to where the project is, we may have to consider using an ARS paint system.
You are even including appearance warranty. You are the electric warranty for 20 years.
Yeah, 2025. The full system is actually tested by BBA for a life expectancy of 40
Yeah.
years.
Just have to there'd be a qualification, there'd be a questionnaire you'd have to fill in, and then the guarantee process will go through. We do VDF finishes, so you've got high gloss retention, good colour fastness, scratch resistant. Lots of different colours can be considered, including metallic colours, good weathering characteristics, excellent UV performance. 25 microns thick, so it's slightly thicker, 30% gloss level, and again, good appearance up to 20 years. These are different PDF finishes we can offer: 2 coat, 3 coat, or 4 coats. And recently we've introduced a HPS colour system. Again, offers good performance, good characteristics, UV stable. So we've got a good mix of colours and finishes we can offer to meet any architectural parameters. Okay, we'll look at thermal movement. The CalZip system is continuous length normally. We do the longest roof scheme we've done to date is 225 metres long. 225 metres long, single sheet.
225.
Yes. And so these will be roll formed, so the coils will go to site, produce the sheets on site. And because we introduce a fixed point to control the thermal movement, we have to look at the forces generated when the aluminium expands and contracts. So this is some work we've done at a certified test centre. Different colour options: stucco, mill finish aluminium, light coloured aluminium, dark coloured aluminium. This is the sort of temperature ranges you come across, and this is the sort of movement you expect in millimetres per metre. Okay, so you're looking there, sort of dark colours, you're looking at 2 millimetres per metre of movement. So we simplified that analysis to look at design.
Millimeter by meter, by degree, or by 10 degrees, or 20 degrees, or
It's just by length, so it doesn't matter the temperature.
the first factor is length, millimeter per meter.
Yeah.
So which temperature difference?
It doesn't make any. It just doesn't make any difference. We
If you have
no
temperature for 10 degrees or 20 degrees,
80 degrees. So temperature there, 80 degrees. So we're making it simple. We're not making it how hot or cold it is. We're just keeping a simple design movement. So if it's a dark sheet, 20 metres long, we'll say it'll expand 2 millimetres per metre. So that'll be 20 times 2, 40 millimetres. Yes.
20 millimeter per meter under plus minus 25 degree temperature difference.
If it cools, it'll move, it'll contract. So it's all. I understand what you're saying, but the temperature, it's if it's 100 degrees, we're still going to allow a design movement of 2 millimetres per metre for a dark colour.
My question. Some tenders, some consultants, they will define the temperature movement plus 20 degrees, plus minus 20 degrees. Some other contracts plus minus 25, some
Yeah.
other contracts plus minus 30.
Yes.
This is 20 millimeter per meter based on 20 or 25 or 30.
This we make it simple: 50 or 80. So we're not breaking it down into degrees, 20, 40. We'll say if it's 20 degrees, it's going to move 1 millimetre per metre. If it's 50 degrees, 1 millimetre per metre. If it goes up to 80, so 50 to 80 degrees, then you could increase that to 1.5, 2 millimetres per metre.
Sheet temperature.
This sheet temperature, yes. Well,
For Dubai, you are, which criteria you are considering?
well, we talked about this this week, and you could argue in this region, because temperatures are a lot hotter, this figure you could consider 2 millimetres per metre. So the longer the sheet lengths, it'd be good practice to allow more than maybe increase that to 2 millimetres per metre. At your interfaces, at your eaves details, these sort of things. Okay, does that answer the question? Are you okay with that? Again, we can give you advice, and if there's any conflicts, any questions you're struggling with, we can help. Again, what we have to be careful with is the thermal movement is we have to take on board some assumptions that steel work tolerances are always within tolerance, so we don't create unwanted fixed points. Because if we create unwanted fixed points, you can have problems with sheets tearing at wells, the seams popping through the calcium sheets, and also we have tolerances for clip installation. So again, if a clip's installed out of tolerance, that can cause issues with the thermal movement and expansion of the sheets. we've done some testing. Again, this is to support what we're saying. We've got an independent test centre. It's called SORAM. So we looked at the thermal movements and the forces generated with aluminium clips, and also when we introduced the E-clips 15, 16 years ago. And basically found that the results we've been using historically are still valid. And this is basically what happens when the sheets expand and contract if the clips are out of tolerance. So the sheets, this is a halter clip. This is your support here. So as the sheet expands and contracts, if this clip is installed out of tolerance, you're going to get this rotation, this sort of moment rotation here. So the fasteners, you have to make sure the fasteners are secured adequately and they're designed to accommodate any thermal movement. You're getting this rotation happening. So these are sort of things we'll take on board when we're looking at designs, looking at fastener calculations, looking at details to make sure that the system functions correctly. So this is a problem what can happen. The clip was installed out of tolerance. It's only happened here, so it's not happened anywhere else. So it's like a localized failure with long sheet lengths. So the halter clip has punctured the CalZip seam. How it would be solved? In this, luckily this, we were able to examine, we unzip the sheets, lift the sheets out of the way to see what the problem was. In this instance, the fastener hadn't been installed correctly, so we were able to replace the clip. We do a small weld over that area there, put a new clip in, new fasteners, and the problem's solved.
How many times it's allowed to zip and unzip the sheet?
We say, why would you want to unzip it?
For example, let's say we have cement angle.
Problem. Oh, no problems. Yeah, we say we don't like to. If you have to unzip it, you have to unzip it. Yeah, but what we say sometimes when because it's
The performance of zip it one more time is the same.
it depends how good the person is who unzips it. If you imagine the seam is like a clock face, and the seam when it's in the correct position should be at like the 4 o'clock position. If they unzip it and then they re-zip it back again, if it gets to 4 o'clock position when it's zipped, that's okay. Sometimes it may only be 3 o'clock, so you may.
The material itself at one time.
Well, it's only one. You'd probably want to, because the more you do it, you kind of work hard on the material. But we have a repair strip, which is what we use when the sheet has been unzipped and re-zipped and it's not zipped correctly. We have a cover strip, repair strip, which we can zip over the top of the seams, so the performance is still suitable.
Omega, right? You put it on the top and it's better. So 1, okay, 2, you will be risky. You need to look, is it reaching the 4 o'clock position? If reaching the 4, maybe the material is still okay. But if it is little up, or you give it one more time, better put the omega, otherwise it will be.
We
Yes, it comes exactly the shape of omega. So you put it and put the zipping machine so it will hold it.
So this is just saying aluminium clips, you get more metal to metal friction. With the E-clips, because they're polyamide, the aluminium top sheet moves, expands and contracts freely over the E-clips compared to the aluminium clips. So these are the E-clips. These were introduced probably 15 years ago. Polyamide with a steel reinforcement. So that in-plane force we talked about is dramatically reduced. So it's beneficial in terms of the fasteners, how many fasteners you need. The sheets are a bit more flexible than aluminium clips. Sorry, these clips are a bit more flexible than the aluminium clips. So they're more forgiving for out of tolerance installation. You can potentially reduce the number of fasteners you need. And what we say now, for sheet lengths over 40 metres or effective sheet lengths from where the fixed point position is, we recommend you use E-clips.
You need area 40 meters straight or curved?
Don't make any difference. Length, just fixed point, so it could be curved or straight. You just say introduce E-clips.
Whenever you have a sheet longer than 40 meters, we recommend going only for the E-clip, which is the polymer. Because movement on it is much smoother. It should be a free 40 meter. Once you lock it in the middle, we consider this is the effective length. Let's say that the panel itself will give crinkling. So over the experience, we designed this clip, one side for the thermal and second side is mainly for the movement, on curved and on long sheet.
The steel reinforcement. So the holes are for the injection moulding process to adhere the polyamide to the steel reinforcement.
When you are covering the steel with mold, if you keep it all in one without the hole, it will not come and fit properly. You have to. That's the, but it has nothing to, it's only the design.
This is alternative to
No, this is a normal clip that will allow the sliding. Fixed point you explain.
When you have more than 40, don't go for aluminum
Yeah.
halter.
Again, this is some analysis again we've done with thermal movement forces. This is in-plane force with aluminium clips. This is your sheet length up to 25 metres, 25 to 40, greater than 40. So the force, that moment force at the head of the clip is 0.42. With 25 to 40 metre sheets, that goes up quite considerably to 1.16.
For the normal halter, not for the fixed point.
This is just, yeah, well also we can design a fixed point to accommodate these loads.
This is the force that will come on the sheet if you are putting the aluminum clip. So imagine the sheet is 25.42. 40, which is only 15 meters longer in length, which is the
But
one
this
that
force on each clip,
on
on each slide, on each clip which allow the metal to slide above.
exactly. So it is putting a force, plain force, on the clip itself.
But this is what we'd look to. You could look to design the fixed point as the datum. The fixed point would be designed to accommodate this load, the fixed point. So we'd have like a nut and bolt or maybe 2 rivets for the fixed point datum, and then maybe 4 clips, 2 clips in the base of the clip, and then subject to 25 metres.
But this force is not for the fixed clip, it's for the normal one, right?
That's up, yeah, that's the force. But this is what we designed the fixed point to accommodate. Okay, so that's the datum that controls the thermal movement.
The force on the normal, not the fixed point, is always zero, negligible.
Well, yeah, depending what's, as long as it's installed at intolerance. But what happens, the sheets may rotate a little bit and then pop back. Because you hear when you're on site, you hear the clicking noise, yeah? Because that's only, it's clicking over the head of the clip. So,
Is what you're saying for 300 wire or for
yeah, that's right. We look at the worst case. We're assuming these figures are assuming the worst case. Clips slightly installed out of tolerance. Worst thickness 1.2. So these have got a bit of safety factor in there. And again, this is the same comparison but using E-clips. So you can see there how that in-plane force is a lot less. And look how, so you're looking there, 80 to 100 metre long. So if that's a curved sheet, that could be 200 metres long. You put the fixed point in the middle. So the effective sheet length on the fixed point is 100 metres. So you can see how the benefits of using E-clips with thermal movement, it's thermal expansion and contraction.
Normally, which is cheaper, the E-clips or the aluminum clips?
Speak to Tony. Yeah.
But we need to go for it because you see the big
I know.
difference. economically want to look at it as really paying more.
Do we stop for welfare break or?
What we have to consider here, all our roads, normally, we have ventilators, we have something fans, we have low lights, we
Yeah.
have skylights, we have couple of issues.
Why do people put these holes in our roofs? We don't like these holes. We have the same in England, yeah, all over the place.
So, what we have to do all around this one, because all the problems from the movement, we notice are breaking the solar panel, breaking
Yeah.
the aluminum. What we have to do to enhance or avoid this kind of problem?
Well, this is depending. This is the details you design at the soakers, or the penetration details, making sure you're allowing enough movement for because the soaker should be a two-piece, have an inner piece and an outer piece. The outer piece would be the cowl zip, and that should be able to slide and freely expand and contract around the penetration. Depending how many wells and where they are, you could put the fixed point where the wells are and allow expansion, reducing the amount of movement. So expansion would take place up at the ridge condition and also at the eaves condition. So there's different ways.
Sometimes, first of all, the deck sheet is part of the structure which is normally, let's say, air conditioned warehouse.
Mhm.
So, constantly at 25 degrees, let's say.
Mhm.
And the top sheet is, according to the weather, it's ranging between summer and winter around maybe 50 degrees or 40 degrees regardless. So the top sheet is always in movement, and the bottom deck is always, let's say, at the same temperature.
Mhm.
So you have the movement on the up.
Mhm.
So, okay, I have one skylight. I can move the fixed point and put it near to the skylight on both sides, and if the system breathes for the other two areas.
It can move. Yeah.
Sometimes I have two skylights
In the same line.
on the same line.
Yes.
So the piece between these two, if I put the fixed point down, so I cannot avoid top, the differential movement. If I put it up, I have
You-
the problem down. Similar if you have, for example, gutter fixed, etc., etc. So sometimes you cannot always control the location of the fixed point. So what do you have to do?
So you're looking to reduce the amount of movement. So you've got two roof lights. You could put the fixed point between the two roof lights. So you're still reducing the amount of movement. The detailing around the roof lights, you need to consider that. So you need to make sure that the upstand of the penetration coming through from out through the roof and the upstand with the cowl zip penetration, there's enough movement to allow that to freely move. What tends to happen is people don't allow enough movement around the details, the interface details, like we say before, 2 millimeters per meter. And also during installation stage, because the sheets can, in the morning they can be longer, sorry, in the morning they can be shorter, and in the afternoon they can be longer because they've expanded and contracted during the day. So when you installing penetration, you've got to make sure you allow enough movement for your details, for thermal movement, subject to sheet length. That's what you need to do. And also, the grade of aluminium you're using for welding needs to be the same grade as cowl zip material. So, because that'll be the weak link and that'll tear.
Which type of accessories make what you said now, allow for movement?
Or if you
Yeah,
have standard
I can-
detail.
I can
Yeah, we have
put
standard
for
details.
here.
Yeah, we have standard details.
Here is sliding clip, yes.
We put sliding clip there. We have, no, that'll be abutment, so that'll be metal flashing. So we have a clip, the metal flashing stick.
No welding
No,
in
most
this
of
area.
the time they use welding.
No welding in this area.
I don't understand this detail.
Right. I'll show you the details.
ما في welding.
I'll have to go stop the presentation, show you detail, and then go back to presentation. Is that? Oh. Will I be on the Wi-Fi here? Can I connect to the internet? No. I can send you some details. Maybe we do. So do I have a break? 5 minutes? 10 minutes? 15 minutes? Might be a long time.
You want internet?
Yeah. Well, I got that.
You have the password?
Oh.
Amana guest, is it?
Yeah, yeah,
This? This? Come down.
Scroll back.
or maybe, yeah,
In the beginning.
didn't open.
Oh.
Just one question. In the beginning of your slide, you put the decking panel, but there is no vapor barrier. Is it not
No, we're not. You sure?
the first one, the first slide? It's not shown that. Is it a different
No.
system?
No.
Or
It's
it should
always
be
a bait.
there, but
Always.
maybe there.
Maybe blame the person who did the slides.
Okay.
Wi-Fi network. What happened?
السؤاليات كلهم عنا اياهم بالمشاريع
لوجن؟
خبرة هيك نركز عايشينهم
Or did it just
هيدي
What do you
اللي
want?
لازم
I want to
تستفيدوا
just get
منها.
on the internet,
هلا
so
خبركم هو
I need
نحن شو عنا بس
I need to get on this net. I need to get on the net extender.
لانه عايشين
This I need to log on. I need to get onto the
Okay,
internet.
that maybe the VPN is blocked. Maybe
Okay.
this is VPN, right?
Yeah, yeah. So
Yeah. So maybe it is blocked. It will not allow from the network. It will not allow. Now internet is there on the laptop.
okay, I click on there then, yeah. So it's under there, yeah. Sorry. I understand now.
Username.
Yeah. No, it's this one. It's okay. This one. So this I can connect then to my
Yeah.
drives in England.
Maybe some VPNs are blocked.
Yeah, it's okay. It'll do it now.
Okay, let's see.
There you go.
Connected, right?
Yeah, I'm connected. Great. Good. Maybe just a bit. Yeah, it's connected, so this should open now. Yeah.
Yeah.
Yeah, just slow. It's coming.
It's a big file.
No, just a long way. It's okay. I think it was doing this yesterday. It just seems to slow. Yeah, there we go. Yeah, there we go. Great, thank you.
طبعا بيلغوه مع شيء بيوجع. ليه؟ لانه بيجوب اسرع من كمان هيك ما فيك تحط في راسه مشان هيك ما بتحطهم بس بالماتيريال اللي جوا بس بيكون بيوجع لانه حاطط جوا نون فايروس ثريت اني منهم.
So going all right? I think it might be a bit long. Yeah. Yeah. We started late, so that's probably why it's going to run on slightly. Yeah, have you got, is that yours? Yeah, get one, thanks.
There is a coffee outside.
Is there?
Yeah.
Okay. Did you want a coffee or anything?
I'll go.
Okay. Just let's see this. I'll just open this drawing, then you can see what we're trying to talk about. Right, get a coffee, eh?
ओके ओके निकालो
चार पाँच लिए ना पाँच है
नहीं कितना टोटल कितना रखा है
चार चार रखा सर उधर रखा अगर ठीक है
टोटल 6 कार्टून इधर बाकी भरा है ना हाँ इस पे आदमी नहीं है ना इस पे आदमी नहीं है ना इधर मैनेजर के पास इधर इधर सेंटर में
It's just out there.
This is part of the problem that I've seen here too many times. It's exactly that. They bind the flashings
Yeah.
so that when it moves, there's no movement in the flashing.
That's right.
The flashing itself doesn't move, and what happens is it kicks it that way. You know what I mean? And
Yeah.
it works the flashing or the
Yeah, so basically, it
weld.
fails.
Yeah.
I don't know if this is
Tears
working.
the weld.
So yeah, this corner, that's what happens.
Yeah. That should be it. That's it. That's exactly it. To allow the expansion gap.
Yeah, that's what it should do.
Yeah.
But probably don't.
Yeah.
That X dimension needs.
Needs to be well.
Yeah.
If it's 10 metres between
Yeah.
the sheets, then you've got.
Hello. Not this. No, sorry, you can't do that. Because this is a training course we get sponsorships for by the UK government. So when people come on the training courses, they get a grant for. Say. Yeah, the bit at the front that Tony did. I can share that with you, and I can send you CAD details. I can give you these. There's also information sheets. I can share information sheets with you on the presentation, like thermal movement, So you get curves, that sort of thing. I'll have to get him to get in touch with Tony. If they want any info, what info they need. I mean, out in case we'd have to come back in to see him and see what they want.
One of the things that we'll maybe need to check is just on the how you value the suitability of PIR with DCD.
Yeah, it depends what U value is. I mean, we only use that. It's to achieve sort of U values at 0.11 or 0.1.
Yeah.
But I think speaking to the lads yesterday came in from Intertouch and the other one, like 0.18 standard U value.
Yeah, they don't tend to be too low. I can only imagine. I can't remember what the setup was on that highway, because that was one where it was a temperature controlled warehouse. So you did have
Yeah.
it's completely
Yeah.
flipped from what we're used
Yeah.
to. You know what I mean? We're used to
Yeah, so it's cold.
warm
It's cold.
interior, cold exterior,
Yeah,
whereas
so-
here
Yeah.
we've got warm exterior, cold interior.
Yeah.
So, but it was just say it's exactly the same theory. You're just working it in reverse. You know what I mean? The temperature differential.
But we still put the VCL on the warm
Yeah.
side because
Yeah.
where the Calvin system breathes. And we've done some analysis. We've actually got a report done. Because people asking just to put the VCL on the outside just to stop that sort of
Moisture drawn through.
potential moist air, humid air coming in. And we said no, because if it does come in, it'll just stay on the insulation level and then it'll evaporate. Because the Calvin system allows breathable. That's right. Yeah.
But that's the thing as well. A lot of even that, for the sake of that, what I've noticed that we do over here is that most or a lot of the installations are foil faced.
Yeah, someone was saying that yesterday.
So foil faced at that site, that prevents
Yeah.
the ingress of moisture into the insulation in the first place.
So it'll be rock and it'll have foil on bonded to it. And the foil we put that on the outside.
Yeah.
They don't tape it though, do they? They don't tape the.
Depends
did you-
on how strict they want to be.
And that's basically to stop the
The
moisture getting drawn in.
into the system.
Yeah. Yeah, just so it'll just hold it there.
We had one on the stations and using it in like on all the walls. So it's 50 mil and 100 mil
Yeah.
rock roll, foil faced. So they're saying they're coming back and saying in the drawings, excuse me, behind rain screen, you need a breathing membrane.
Yeah.
You don't need a breathing membrane because we've got foil faced and we're taping the joints.
Yeah.
So there's no moisture going to be drawn into it.
Yeah.
You don't need to stop the moisture
Yeah.
being drawn into the insulation. Therefore, you don't need a breathing
Yeah.
membrane. You need a breathing membrane. It's on the original architect's drawings. Sure on that. That's why you need it. And that's the kind of level that you're up against. But people that don't
Yeah.
are not technically aware,
Mm.
and all they're doing is they're looking at it and going,
Okay, not got
this
that.
is Celtic, you need to have Celtic.
Yeah.
And it's that simple. You know what I mean? It's
Frustrating,
crazy.
yeah.
So frustrating.
So basically, the drawing says one thing and you
Yeah.
tweak it slightly, they expect it still to be like that. Yeah.
I can't even remember, I can't right now remember the setup of it, but we've had details where we've massively increased the capability, the suitability
Yeah.
of the materials. And they're just saying, no, you need to go back to that, but that's wrong, that doesn't work. What we've done is it works. I had a drawing, for a man-safe system. Man-safe system. And they commented on it, the setup of the roof lights are wrong. I've got to do with your man-safe.
Yeah.
You know, as long as your man-safe covers the area of the roof lights.
Yeah. It'll make a difference, doesn't it? Yeah.
Because the original architect's drawings had, and this is where it gets crazy, because the original architect's drawings had a 6 metre single pane
Right.
double glazed unit.
Yeah.
I think the DGUs on that are something like 43mm stick
Bloody hell.
overall. So, and there's a real weight in them. And
Heavy.
they said,
Yeah.
calculated it all out, done structural calcs. You can't have that, you need a central transit. So it was fully agreed.
Yeah.
That's okay, that's what we'll do. But that's what they were pointing at in the man-safe drawing.
Well, got to. Yeah, the same. What's that got to do with it?
That was the thing.
Should we get these?
They've got to, yeah.
Tell Tony to round them up. Hiya.
Deep in conversation yet.
Is he? Who is same lot?
Yeah.
What time do you think you go? About 5?
And yeah, maybe just before 5 o'clock.
So this is a detail. Allow it to move. Yeah. Inner and outer. So this X is
Yes, this is part of the standing seam, and this is
inner penetration. So two pieces. That gap is 50 mil. And then when it's installed, needs to make sure quilt soft insulation. So it can, so this bit sort of float. So but sometimes if the corners here it can crack because there's not enough room, so it stops it here. The sheet wants to move at the sides. This is moving still. Cracked here. And also when you get
but here, this part is with the
Yeah.
this,
it floats.
but this one when this one moves, this one has to shrink. How it will shrink?
No, this here, this moves, or that moves with this detail there. So this is what this one here, that one there, that can move, there's the detail, so it all moves, it floats.
This half of it cut.
Yeah.
Half of it is this one.
Yeah.
So this will move, will take the opening up because this is continuous.
So this is continuous. So it's all welded, so that detail there, you need to allow the movement for it to move.
Sama. هيكون gap on
At the end,
gap on.
لا لا
طبعا
في problem behind. There is problem in this sheet. This sheet, okay, this sheet let us say it's
you fix point here, fix point there.
fixed point here.
Yeah.
No. For this, fixed point is say in the middle.
Fix point in the middle.
Yeah. Far away. So this is meant to move.
That part free.
Free to move. So this one, let us say it's move 5 centimeter towards this side. This sheet, it's one sheet. How it will move? So it will move along with the original movement of this sheet.
But the fixed point, where's the fixed point? That control.
Of course, fixed point, let us say 10 meter away from.
Yeah, 10 meters, so 10 meters.
So this one, how it will move? This piece is move 5 centimeter.
Yeah,
Again,
this piece.
this piece, which is cut this portion.
Yeah. But this sheet is the same, effective, the same length,
The
effective,
same fixed
same
point.
movement. Yeah, same fixed point. Fixed point, one fixed point, in the same place all the way. And this is where you control the movement. So 10 meters, that moves 10 millimeters. Longer at the far end, this is longer there. You cut the drip angle,
This fixed point here, and you need another fixed point. This for this point.
No.
Here.
No.
What?
Because it floats. So if you put a fixed point there, then you stop it and this will move it. So
Yeah, but
there.
you cannot allow two fixed points back between 3 meters. 4 meters is allowed, no?
Two fixed points
Nearby.
near fixed point, but not too far apart. So you wouldn't, but you don't, if you put a fixed point there, well, because this then, this
understand.
moves and this,
So you
but then
make,
it's
you make
there.
all this, you make all this like a one
Yeah.
piece, yeah.
Yeah.
This isometric here
Yeah.
would be
يروح يمشي فوق كله.
Yeah.
full isometric.
هذا
The socket would move.
just
So
All the one point
floats,
one move.
sort of floats, moves
Whole thing.
in unison.
no, but what's Osama, we let's say here in the same line we have another one.
Yeah.
Let's say this one 10 meter. Our fixed point is here. How to treat this area in between?
So we won't put a fixed point there.
Okay. No. Put the fixed point here. And each part of the field. But here,
Skyline.
but here let's say
In the middle. So in the middle.
The same issue. And what you would have is the fixed points here.
yeah.
It's the same theory. This is going to drift.
Yes, but
Yeah,
here
it's
you
going to
reach.
expand and contract.
Yes.
This is going to expand and contract a bit more.
Yes.
All you would need to do is
It means you should increase the curve.
So your
But-
concept is all has to move
Be
in
well.
unison.
Yes. What the worst case that you could ever possibly have is you have the sheets expanding and contracting that.
This is not allowed.
But,
No.
but you are not recommending to cut the sheet here and to not do welding.
Yes, yes.
You can do. You can do.
This soaker would be reheated. So your sheet cut back.
Well, ما بتصفي صفوا the welds. But here,
سويت
let's
gap
say here.
أكبر من الجاب اللي
Let's say
بدك
here I have
Flat
three,
top.
four sorters.
And also, the drip angle at the
We should allow the sheet here.
make sure where the different sheet lengths
Won't-
are,
won't move against
cut the
the
drip
soaker.
angle. So one sheet
Move
can
with
move
the soaker.
along with the other sheet. So
All round.
here, this sheet drops it. So you make, cut the drip angle to the E.
Yeah, the thing is
So you
here,
don't get any
in this case.
different moves on the drip angle.
And what you would have is
تلقى كبر
opening 1 meter على 1.1
Because you can get,
you could potentially have
long sheet,
5 soakers on both.
you put a gap in it.
The benefit would be allow detail in the side wire, take the worst case and get your sheet. You have the same soaker all the way up. You wouldn't need all that moving there. So you'd have identify one unit, same size, same wire. So you get, no, so you have one thing that you allow is all five.
بده يعرف وين يقص الريكتانجل بشكل ما يربطه ببعض ما يخلي يشد يبقى بده ينتبه كمان على عندك مثلا انت رابط هون ورابط هون هنا السويش طبعا اكثر من راح يكون كمان تكون عالي بشكل وهي راح يطول اكثر كده راح يطول اكثر كل هول على الورق لما علموا اياها شي مره هيك الديزاين this will be the other side because your seam is here.
Sit in the front if you want, Tony. Just sit in the front.
So the soccer would be accelerated separately inside and
Yeah.
the whole unit.
What time do you shut the doors? Hey? Okay. Is everyone ready? So that was an interesting topic. We have these on all CAD details. I can send the CAD details to you, or our standard and typical details. And you can use these for your project. So now we'll look at the structural aspects of the CalZip system. So we have low span tables for all of our profiles and all the different thicknesses of material we supply. And we can either use the low span tables, the span against the load or the load against the span. And the low span tables are factored as well. So they consider characteristic values. We look at load factors as well as deflection limits for different regions, different regional variations. So that's a typical load span table we offer. It's coloured in, different colours are it's sort of trying to highlight sort of the mode of failure, where the risk is. So the pinky colour is the CalZip clips fail, the white colour is the sheets are stressed, and the blue is where deflection limit may be exceeded. Okay.
Usually from experience, all the data sheet which we receive from the manufacturer, we are not following the maximum load, and we are literally use only 60% of the load. For example, you tell me my sheet is span freely 2.3 meters. We believe it is actually span 1.8. So does it apply for CalZip?
Well, the utilisation of the sheet is sometimes we can't control where the purlins go. So if we get the wind loads, if you can determine the loads and you can tell the steelwork fabricator. Yeah.
That's something close.
Local.
Some of the manufacturers will be copying their tables from other manufacturers. Those manufacturers, they don't know what is the performance of their panels. And we see it actually in many places. So yes, we need to take a safety factor above what some doubtful manufacturers to be safe. Like our load table is created based on testing.
Yeah.
So we never reached to this based on approximate. For 51 years, we didn't have any
factored.
Neither it is our practice. So the load tables that we give
Factored. Factors. It's got the factors.
They are based on testing. So we can safely use them.
So I understand from you we can go ultimately to the numbers which is mentioned in the table without any
Yes.
factor.
The factor. These are the factors there. Load span tables are factored. So the engineer can give you ultimate loads. Our load span tables are factored, so that's okay. It's fine. So limit state design is when something designed to its limit.
And this goes for the decking and for the upper sheet both, right?
Yes, we have both.
As a system or each one individually?
We can do it for the whole system. So we can do calculations for the deck. Same.
Standard one is for the system or for individual?
There is a load table for the liner. That is the structural side of the liner. And there is load table for the top sheet, which is two different.
Important question. The top sheet. When people walk on the upper sheet,
Mm-hmm.
do you consider any support from the rock wool, compressed rock wool below, or it's totally hang on the
The CalZip,
outers?
the CalZip sheets, you can walk on the CalZip sheets, and we don't consider. You can,
You can.
but you can. There's a way to walk on them. So you don't walk in the pan. You have to walk on the seams. So they've been tested for people walking on the sheet. But ideally, you'd put a board down, and like a youngman's board, and you spread the load. You wouldn't walk in the pans. But if you need to, if you're experienced to work with the CalZip system, you know how to traffic, then you can walk on the seams. You don't want to walk in the pan because you see where you get deformation. If you are going to walk on the sheets, then we suggest you put high density rock wool insulation to support the pan of the sheet. No.
When we design, you send us the documents and we design the project, we usually consider next to the possibly walkable area, like the walkway or the periphery, we put hard insulation without you asking for them, because it is part of the standard practice we do. So where you may walk, we consider, but definitely you should not walk in the back. You need to walk on the seams, because the seams are the one that take the span in the middle, you should not step, for example.
So these are the factors we use to answer your question. So the engineer can give you his characteristic values. Our load span tables are factored, so depending which region you're in, these are the factors we consider for the different load cases. These deflection limits, so we can ME region, are they still applicable? L over 240? Yeah. And then this is a design tool we have. So you've got all the characteristic values, all the different factors we can adjust, the deflection criteria we can adjust, different calcic profiles, and it gives you the performance values for single span, double span, multiple span, for imposed loads, and also for wind suction, so you know the design capacity of the calcic sheet. And it also tells you where the risk is, where the potential failure could occur, if you need to look into it that closely.
All these calculations will be given along this shop floor.
By Tony. Again, that's just an example of the sort of software we use and math CAD formulas, calculation procedures for working out the structural capacity of the system. These are the load factors we can add. These can be adjustable to suit what region you're using the system in. These are the material factors, again, for the aluminium alloys, for the E-clips, for the aluminium clips, for fasteners into various substrates. We can fix into concrete, we can fix into timber, we can fix into light gauge steel. So again, different factors are used for different applications. Different deflection limits we can look at as well, subject to what the project parameters are. And this is just a quick summarisation of the, these are the calzip profile sheets. This is the 0.9 calzip on aluminium clips. So you can see the strongest sheet is the 65305. Here you see, so you've got capacity there, sort of 6 kilonewtons. The AF profile 65337 is a weaker sheet. The wider sheet is a weaker sheet. And that's the same analysis, but with the E-clips, you can see there. Calzip 400 is a common profile, so you can see there it's got quite good spanning performance against the load here. This is just a bit of a comparison of a calzip system against an alternative system we sometimes come across. The main difference with our system is this symmetrical design to the head of the clip, which enhances the structural performance considering wind suction. Also, the base of the clip has options for 6 fasteners. Again, is beneficial for structural performance, depending on what substrate we're fixing to. This is a competitor's clip we've come across on occasion. As you can see, it's not symmetrical, it's directional. So the issues with this type of clip is you have to make sure it's installed with the direction in the right orientation. Also, the base of the clip only allows for 2 fasteners, so you might have to put your clips at closer centres because it's the capacity is exceeded. Also, it's aluminium, as we can use a polyamide clip, so it's beneficial for thermal bridging. I don't think that's come out particularly well, but what this is showing here is the Calzit span. It's sort of 16 or 1.6 meters, 1600 millimeters, and the competition have to install their clips at 860 millimeter sensors. You can see the design capacity of our system is considerably greater. What does that mean for you? Well, that means you're putting all these fasteners in, all these clips in, all these problems with the installation, making sure the clips are in the right tolerances, the clips are installed in the right direction. So your time on site is increased, your costs are increased. Your installers have to make sure that they install it correctly. So with Calzit, we're minimising the risk, making things a lot simpler, a lot easier. Install the sheets, off you go. Any questions?
Excuse me, can you return back to the photo and take that one slide? The vapor barrier,
This here?
the overlap, is it sealed in between?
It should be, but this isn't Calzit. This is copycat. So they've probably done it wrong. Well, that should be sealed. Yeah.
The transit as a system, it could be, is it airtight or watertight?
It's both, but the VCL provides the air tightness.
But it should be covered below the gapper if it's watertight.
The VCL can be dressed into the gutter. Just depends on what the details are. If it's
It's watertight,
watertight, the Calzit system is watertight. Doesn't let water in.
watertight.
Watertight.
And what is the difference between the vapor barrier if it's adhesive or normal?
It's just the vapor resistivity. So the clear VCL reinforced will have better vapor resistivity performance. And sometimes the EPDM self-adhesive is just the lap detail is a bit easier because it's already there, you just stick one onto the other. With this type of VCL you have to put butyl tape in as well. So it may be a bit more time on site. So this is thermal performance, U-value performance for the Calzit system. This is a terminology. Lambda value is the thermal conductivity, and that's a measure of the rate of heat at which a material will pass heat. R value is the thermal resistance. U value in watts per meter squared Kelvin is a thermal transmittant. And that's basically the measure of how much heat will pass through a metre squared of a construction when the air temperatures on either side are different. That's a quick simplified equation. As resistance is the depth divided by the lambda value, and the calculation of thermal transmittance is the reciprocal of that figure there. So that's the external resistance, this is the internal resistance, and this is the lambda value or the conductivity of the inner material. These are your standard Calzit constructions. You can just off the slide there, but we have a design tool so we can calculate all the thermal performance for all our products. Your liner deck system, your liner roof system, and your structural deck system. This is our U-value design tool. So we can put all the Calzit sheets in, different profiles, different types of clips, different clip heights, different insulation conductivities. We have our rock or glass fibre products have a conductivity of 032 to 04 in terms of lambda value. And we can use different insulation products from different regions by just changing the parameters of the design tool. So we can put all the parameters in, it works out the sheet length, the thermal bridging effect of the clips, if you're using ST clips or aluminium clips, and it gives you a U-value performance. Again, this is a little graph to show the effect of the calzip clips and the thermal bridging. So you've got the theoretical, the modelled U value is a dotted red line. You've got the calculation here is a cyan line. The green is when we're introducing ST clips. So you can see there, the more clips per metre squared across the bottom, the thermal bridging effect of the aluminium clips through the insulation. And then when we look at the E-clips, which is the dark blue line, you can see the E-clips don't have any effect on the thermal performance of the system. So again, another reason why you should consider looking at E-clips, because they're good from insulation point of view, they're good from the thermal performance point of view, reducing the risk of condensation and so on. Yeah, we compress it maybe 15 to 20 millimeters, so it doesn't have any effect on the thermal performance. Still the same, yeah.
And then it must be compressed, right?
Yeah,
Use the air gap.
that's correct. Yeah, we oversize it and just get rid of any air gaps, any pockets of air. So it's maybe 20 mil oversized and just compressed down. That's a glass fibre like product. Sometimes if you're using a rigid product, you maybe have to order that undersized because that doesn't compress. But for the glass and rock fibre quilts, they're always oversized. So again, as we introduced the systems before, we talked about acoustics and what we can do from acoustic perspective. So roofing systems have an important role to play in achieving the required acoustic performance. Design teams need to consider the sum impacts of all of the components of the room and not treat the walls and the roofs, etc., in isolation. We have to take a holistic approach. So we break acoustics down into 4 categories. We've got sound absorption, we have airborne sound reduction, we have impact noise due to rainfall, and also we have flanking sound, which is a detailing issue when it's the sound flanks from one room to the other. Especially there, you can see you get a lot of sound transmission through the flutes of the trapezoidal deck profiles. So in this classroom, for example, here, this could be a quiet room. Next door could be a noisy room. So we want to make sure the noise from this room doesn't come through the deck profile. So we've done all acoustic testing for all these types of acoustic criteria. And this is what we can do from acoustic point of view. It's a standard calzip system. We can look at different insulation products to add mass. We can look at cementitious boards, again to add mass. Acoustic membranes add mass, so we can achieve, by adding these components, quite exacting acoustic requirements across the full range of the octave bands. And also, with impact noise, rain, banging on the calzip metal roof system, we can also we bond an anti-drumming membrane to the underside of the calzip sheet to reduce that radiant impact noise. You use that quite often in the UK in a lot of schools where it does rain quite a lot, so it's beneficial from the school's perspective. Again, that's a slide similar to the one we showed you before in terms of this is now sound absorption, where we perforate the liners or the decks. And do you get involved in acoustics often in this over here?
Yes, because airport project, we have a lot of airport projects.
Yes.
Sometimes the offices and spaces require some acoustic system.
Okay. So again, we can give you a lot of advice there. We've got like 80 plus acoustic test reports considering all sorts of different criteria. We have a design tool where we can predict sound reduction performance by adding different layers, different masses, etc. So right, okay. So you have the spec sorted. Oh, like suspended ceiling or something.
Sometimes, no, not
Yeah.
suspended ceiling,
Oh,
sometimes
under drawer.
sometimes-
Yeah, we've done similar. That'd be for sound absorption. Yeah. Yeah, so we sound absorption, perforated liner or deck, acoustic slab, top hat. Vapor control layer is a hard surface, so the vapor control layer is positioned above the acoustic slab, so that the acoustic slab absorbs the sound energy, the sound waves. So we can offer perforated structural decks, perforated liner decks, web perforated for the decks and liner decks. The liner is trough perforated. We can also introduce acoustic slab, which is 30mm high density rock fibre board, or we could introduce acoustic lags, which are profiled to sit in the flutes of the trapezoidal profiles. This is airborne sound reduction. Again, it's measured in 1/3 octave or full octave band frequencies. Sometimes acousticians will want to know what the performance is at different octave bands. So if you look at our acoustic test data sheets, we can get a rough idea of how systems are going to perform. And they also sometimes give you a single figure RW value. With sound reduction, the higher the RW figure, the better the performance. So from Calzit's point of view, to enhance sound reduction, we can look at adding mass, we can look at insulation, and we can look at isolation. The E-clips do have a benefit from a acoustic point of view because they act as an isolator from outside to in, whereas the the aluminium clip can be defined as an acoustic bridge because that connects the outside metal to the inside sheet. This is information sheets we can supply to PDF copies. This is showing you about the acoustic board. You can put these in your design packs, take them to see architects, or Tony can. So these are sort of things we can do in terms of achieving exact acoustic performance. Again, I don't know if you get involved with acoustics too much, but this is showing the relationship between frequency and mass. And this is the bit we can control is sort of mid-range frequencies where we can add mass to our systems. We struggle at low end and high end acoustic performance. So here the system can be too stiff and it starts to resonate. And here again it can start to sort of vibrate because it's at the same acoustic sort of harmony as the actual sound itself. So you get vibration.
For you, a concept is how much sound reduction index you are going to achieve.
That's one way. There's sound reduction. We can consider sound absorption as well. So we break it down to 4: sound reduction, sound absorption, impact noise, and flanking sound. So we can give advice on all, but the main one really is noise reduction, either outside to in or inside to out.
So for different kind of tools, you know, or you be able to give us how much the sound reduction dBs
Yeah.
between outside and inside.
Yes.
This is what you can control only because outside you cannot control the hardware side, right?
No, but the design team will give you, say, the roof should achieve 44 dB at RW. So we can look at our database, or we can put a predictor in and say this build up achieves what you're looking to achieve. Like I say, we've got 80 plus tests done for RW performance, noise reduction. So
Standard system, you're saying 20 centimeter of wood, it's a standard system. Approximately how much sound reduction can I need? 40 dB, 50 dB, 30 dB?
that'll achieve between sort of 37 to 40 dB. Yeah, with 200 mil insulation. Just what like rock fibre, say, density, what 23, 27 kg meter cube density.
37 to 40, up to which extent we can enhance it?
We, depending what flexibility, we've done a test and we've got 52 dB. We've also done another test where we've put underdrawn a ceiling below the purlins and we've got 71 dB, so we can got a bit of flexibility. We have a specification for cinemas where it has an acoustic board in, 10 milli board and high quilt insulation, and that achieves about 49 dB, and it's a simple construction. Sorry, that was just showing the difference. This is the E-clips and the aluminium clip. So you've got the same build up except for an E-clip or an aluminium clip, and you can see there with the aluminium clip you get 41 dB, with the E-clip getting 43 dB. So the E-clip is also beneficial from acoustic with sound reduction. These are just some observations and guidance from acoustics from our point of view. So lightweight metal constructions, which Cal Zip is a lightweight metal construction. You get poor performance at low frequencies, and that's when we saw that. We showed you that straight line and the resonance dip. We're trying to increase the mass to extend the SRI curve. Complex multi-density layer forms of constructions can improve the SRI, sound reduction, and also improve the LIA, which is the intensity within the room. Perforated liner decking gives you efficient mass for mass SRI performance, as well as giving you sound absorption benefits. The anti-drumming membrane, which is bonded to the underside of the pan of the Cal Zip sheets, is good for simple forms of construction, i.e. single layers of insulation. Low density insulation also acts as an isolator as well as an insulator, and should all be used as a first layer below the Cal Zip sheet for your thermal performance. And just adding mass on its own can cause an acoustic bridge, so it doesn't have any benefit from acoustic sound reduction. And as I showed you, the E-clips are beneficial from sound reduction points of view. Any questions there? Have a quick look at condensation. These are sort of some of the terminologies you should come across. You've got vapour resistance, which is resistance to a passage of moisture, vapour, to a layer of a defined thickness, i.e. the Cal Zip sheet or the vapour control layer. You have vapour resistivity, vapour permeance, and vapour permeability. Okay, it tells you there what they mean. These are the ISO standards, international standards we work to. So ISO 13788 is a steady state heat flow assessment. You've got standard terminology and calculation methodology we have to adhere to. It's based on a month-to-month calculation, so it's a Glaser methodology. So you can look at the condensation risk all throughout the year, from December through the summer months. So you can see exactly where the risk of condensation does occur. We also look at European Standard 15026, which gives you the hygrothermal performance of various different types of building components. And again, these are the type of buildings. We break the buildings up into different humidity classes, so you can determine how what the risk of condensation is, and possibly what sort of vapour control layer you need to introduce. These are the internal temperatures you may come across. These are the relative humidity figures. Again, this is showing you how these buildings, what sort of moisture they can have as the temperature changes. This is a graph showing you we've done some finite element analysis, so like hot box testing. So we're trying to look at surface condensation and the risk of surface condensation. So this is the model here. This is a trapezoidal liner. This will be a top hat clip, and basically the temperatures is on the, you see the temperature gradient on this side here. So this figure is the F factor, and we're trying to determine the risk of surface condensation forming on the underside of the construction. So it considers the surface temperature, it considers the external air temperature, and it considers the internal air temperature. So we can change these, and we can model the risk to determine whether surface condensation will form here. And this is the, depending on what the building classes are, this is the F factor figure. So you can see if it's high humidity, you need to make sure that the F factor, the internal surface temperature, is less than is greater than 0.9. And this is a summarisation of the F factors which we've achieved by using the E-clips and aluminium clips, different insulation conductivities. So you can see with the E-clips, the F factor is always greater than 0.9. With the aluminium clips, the F factor reduces slightly. So depending which building class you're using, which building class you're involved with in terms of the humidity, there could be a risk of surface condensation forming. So to summarise, when using ST clips, there's a minimal risk of condensation forming, but you may get some condensation forming on the screw heads where they penetrate the structural deck. With E-clips, again, there's no risk of condensation forming. And again, we can give you advice in terms of what vapour control layer you should be using, subject to what humidity class or level the building is.
All these studies that you were, sorry, I think you were asking about VCL. So all the studies that you were mentioning one by one will define what type of VCL you need to use. Because the condensation is what usually kills the system. If you're having a system that's having condensation inside, that will destroy. So all these studies, one by one, type of building, class of building, all these combined will let us tell you what type of VCL to use to avoid that vapor to cross
The dew point. So these are the condensation risk analysis design tool which we use. Again, we can put the build up in different temperatures, and that will determine whether there's any risk of condensation forming. This is a model. So this is inside, this is outside, this is the dotted line is a dew point, and this is the temperature gradient through the construction. The idea being that these two should never meet. And you can see there, this is outside to inside, showing the temperatures. This is the risk of condensation. No. So there's no risk of condensation with that construction. This is a software tool that we have. And this is just a comparison to show you. So what's happened here? Go on. This is dew point, this is the temperature. It's getting cooler. Do you think that's where condensation is forming? Yes. So here, the red line isn't touching the dew point. So there's a risk of condensation at this area within the construction. And that says there, yes, that says. So we can do this analysis for you based on all the information we've got to determine whether there's going to be risk of any condensation forming within the construction. Again, this is just a little summarisation showing you how much the warm air contains more moisture, and as it cools, the moisture has to go somewhere, and that moisture normally occurs within the construction or on the surface of the internal liner or ceiling. So this is just a rough example of how condensation forms as hot air cools. So a couple of considerations in terms of your vapor control layer. So it restricts the movement of moisture, vapour from inside the building into the roof construction. The VCL should always be installed on the warm side of the roof construction, below the position of the dew point temperature. That's where you can get condensation forming. Some cases you may get external temperatures warmer than the internal temperatures. The VCL acts as an air barrier. More moisture can travel through construction via airflow, convection than through diffusion. And it's relatively okay for construction to occur above the VCL, as any accumulation of moisture can usually discharge into the gutter. Things to be careful for with VCLs is make sure the laps and penetrations are all fully sealed, and interfaces. Ideally you want the laps of the VCL to coincide with the crown of the deck or the liner deck. And also the VCL type in terms of vapour resistivity should be determined by the building class and how much humidity there is likely to occur in that building.
VCL in the corner of the gutter, is there any detail enabled to not cut? Because in this area you have sharp edge. If the VCL should continue below the gutter. So is there any detail to cover this edge? Otherwise it could be broken in this.
You can either, as the VCL comes down and jesses into the gutter, and on the sharp edge where it could get torn. You could, if you put a flash in, you could put a metal flash in, like a closer flash in, to sort of hold it in place so it's not exposed to that edge. So you put a closer flash in, which is sit on top of the liner, and just protect that edge of the VCL so it doesn't get torn. That's one way of achieving or protecting it from getting torn. Another benefit of the CalZip system is the seams are the weather tight, but they're not airtight, so the system breathes. So any moisture within the construction will, over a period of time, evaporate. So during construction stage, if you get any moisture in there, once the CalZip sheet is on, providing the weather protection, any moisture will evaporate over a period of time. That's one of the benefits of the CalZip system.
How long can be exposed to sun before we put the rock wool and frosting?
As soon as possible. You don't want to leave it out for too long. So
Like 1 week time?
you probably a bit longer than that. You're probably looking maybe a month longest. Because as soon as the trouble is, the longer you leave it, the more exposed it is to tears.
Depends on the weather.
Well, the weather, but also even the weather, because people are going to be walking all over it, so that can damage it. The lap joints could maybe start to open up. So if you leave it exposed, then you have to make sure that when you put the insulation over the top, that you maybe do an inspection to make sure that there's no areas where the VCL is damaged. But it's quite UV stable, but it's just over a period of time people are going to be walking all over that and damaging the VCL.
Is there a particular season where the inspection is necessary for on the
Ideally when it's dry and not wet. But it's just as long as you can get If it's wet, it's more difficult to install. Because it's just not nice working environment. 'Cause it's, but if it's dry. Ideally, it's perfect for this region then. Everyone's happy. This is just a bit of a consideration when you're looking at acoustic performance, because you just have to make sure that this insulation, the thermal insulation, is at a ratio of 3:1 above the thermal insulation, the acoustic insulation. So normally acoustic insulation is a 30mm slab. So to make sure we don't get any condensation forming here, we need to make sure that the thermal insulation is sort of 3 times greater than the thermal insulation. We've been asked as well about the vapour control layer for different regions. So again, we've done some testing, funded some testing. This is at the University of Buildings Physics in Stuttgart. We've looked at different regions, different temperatures, different levels of humidity. And the calculations considered a 10-year period in line with EN 15026. So we looked at a standard construction, different levels of insulation, vapour control layer, trapezoidal liner. We also looked at an acoustic construction with the acoustic slab, vapour control layers, different levels of thermal insulation from 20mm to 160mm. This is with an E-clip. And you can see there the results show this minor level of condensation does occur, but it's well within acceptable international standards. So again, from a condensation risk point of view, the Amana DIP system performs well in a whole variety of different climatic situations. Any questions?
Regarding the pre-curve sheet, what diameter will it go for pre-curve sheet?
Below 40 metres. So the Amana DIP straight sheet will self-curve up to 40 metres. So below 40 metres you have to get it factory curved using 0.9mm material. 1mm is 45 metres, 1.2, 52 metres. So that's a convex curve. Okay?
Regarding that will be done outside or in the customer?
It depends. The curve machine can be delivered to site.
Say I have a building with 90 meter width.
90 metres straight sheet, that'll curve itself. 90 metres. Gauge. 0.9 natural curve, minimum it'll curve to is 40 metres convex radius. So straight sheet will self curve to 40 metres, 0.9mm material. Yeah.
The thickness of the sheet, if it is 0.9, it can self-curve, yes. If it is less, we will send the crimping or smooth curving machine to site and it will curve. So it needs to be pre-curved before you do it.
As an installation wise for the curve, is there any difference between the curve and the flat? Let's say as a tolerance for the harder, normally for the flat,
Yeah.
taking from 10%.
It's a bit.
In the curve, what is the tolerance you recommend to have?
If it's aluminium clips, we suggest aluminium clips. You set the clips out maybe slightly wider, 402, 403, because normally with straight sheets, the Amana DIP it rotates into position, but with curve sheets it won't rotate in, so you have to drop it onto the head of the clips. So if you're using curve sheets with aluminium clips, we suggest you set the clips out plus 2mm, 3. So it's 400 Amana DIP, set the clips out at 402, 403. So the sheets will drop on to the.
And it will not affect all. Let's say you have 100 meter.
Well, just you just have to make the details will determine the setting out. So if it's you may have to ideally it'll stop in line with the building and you just close it off with the metal flashing. So
Or you should have an extension.
no, don't need expansion. No, it's just the way once it's 403. If we're all set out at 403, that's fine. It's okay, not a problem. It's just to make sure that it sits correctly on the building, so you start and finish points and where your metal flashings are. So it's just about your interface details and setting out. But
You take the last sheet, so 3333, the last sheet, you need to do either the full sheet or half sheet. In terms, if you follow all the way to 303, so
yeah, if you've got an interface, you might have to put bigger flashings in. It just depends what the profile is, what profile you're installing, what your interfaces are. So calcit, because long sheet lengths were all formed on site, we have to control the thermal movement. So with the thermal movement, we introduce a fixed point, acts as a datum, and the fixed point avoids the calcit sheet from creeping off the roof, off the supports. It considers the dead load and it considers the snow load, and only one fixed point should be introduced into each calcit sheet length. That's a quick formula for working out the fixed point force. Has anyone seen that before? No. That's okay. Probably the last time you'll see that, because we can do all these calculations for you. Again, this is what we talk about, the fixed point force, where you get this expansion contraction at the head of the clip. Well, this is the design tool we have, which we can work out the fixed point force for you, whether it's 2 rivets, a nut and bolt fixed point. So it considers the calcit sheet length, looks at the roof pitch, looks at the imposed loads. So we can put all that criteria into this design input boxes here, and it works out the fixed point force. Okay. So when you're doing your designs, you're doing your details, and you want to know what the fixed point should be it be a nut and bolt? Should it be rivets? If you give us this information, we can put that into our design tool, and that will confirm what you need to do at the fixed point.
depending on the situation. Mostly if it is big, you need to go down and down.
How do you shift it? If you shift it, will it be
Either,
effective?
yeah, a beam and you lift it. We have done, we have several ways to
You have equate altitude control right here, and this is it. Now
I have seen, for example, lifting beams, they will take it all the way with the length appropriate to the curvature and lift it. For straight, usually we do upward, downward.
Well, the curve.
How can you dash
Well, just the pallet. You put the sheets. Yeah, you can either look at a lifting beam, slings, and depending how heavy the crane is, maybe they could have 10 sheets lifted, 10 sheets lift up onto the roof. You won't put the kit up onto the roof because with the curved sheet, you roll form the straight sheet first, and then you curve it on the ground, stack it, and then lift it with a lifting beam. The fixed point. Well, normally, if 100 metre long sheets, that'll be a barrel vault that'll be curved. So we just put the fixed point in the middle. So, and also, if it's a steep roof pitch, we may sometimes put the fixed point in the middle. Just depends what the sheet lengths are. But normally, the fixed point is at the ridge condition, and the sheet will expand into the gutter if it's straight sheet. If it's curved sheets, we put the fixed point in the middle. It could be, say, we did a job, the sheets were 225 metres long. We put the fixed point in the middle, so it's 112 metres, just expansion, yeah. Sometimes you may have a roof pitch, maybe 5 degrees, and it has lots of penetrations in the roof. So we may put the fixed point in the middle, near where the penetrations are, so you don't get as much movement around the penetrations. Gutter. Yes. 100 millimeters more. Yeah. Yeah. It's okay. Yeah. Just to make sure that the gutter, the upstand of the gutter, the drip angle doesn't foul. So you make sure you have enough room for the sheet to expand and contract. Just design your detailing.
You notice at the end of each section, condensation, load, Adrian is mentioning we have a design tool. Design tool is actually a tool developed by our engineers that combine testing plus formula. So whatever formulas are there or testing, we created that to make the work easier for all our operators. So it's designed and work done, run the name of this. We have it here. We simply feed, let's say, this is the lens, and put all the details in that tool, and it will give us, it's safe, for example, to go for a better, or better to go for a goal. So all these tools are developed and done specifically to suit the project to value.
Yeah, so we can give you lots of support. Any questions, just send us emails, phone Tony, you phone me. So just look at wind loads. So gales, high winds can cause damage to properties. This is basically a simplified picture of how sort of wind acts on the building. You have to be careful or consider any dominant openings in that building, and we also have to look at the positive and negative effects of the wind on the roof. You've got this positive pressure here, negative pressure, positive pressure, potentially negative pressure here as the wind acts on the building. Ooh. At the corners, this is usually where the wind acts the strongest. So you get these high wind pressures around the edge of the building, high negative pressure at the corners where the wind hits it and changes direction. Inboard, the wind sort of slows down, so you get moderate negative pressure. So again, when we look at our design tools, we can optimize the performance of the CalZip system relative to the wind loads at the corners. We can put in more fasteners, reduce clip centers. Inboard, we can increase the clip centers, so it gives you a cost benefit. This is just an example of sort of how we do that. This is a flat roof with a pitch at 5 degrees. These are the pressure coefficients in line with the standard. So at the corners you add a pressure coefficient of 2, which is here, the zone A. Perimeter, zone B, is a pressure coefficient of 1.4, and C in the middle is 0.7. And these are the loads acting in these areas. So you can see zone A, you've got a higher load. Zone B, reduced load. Zone C, reduced load again. So if you're on a structural deck, this is where you can put clip centers closer in the edges and at the eaves. In the middle, you can increase the clip centers, so that'll have an impact on your costs, on your installation time, and how the system is installed. We could look at all sort of different loads, different standards applicable to different regions, and we can change the design tools to suit the different regions. But ideally, we also always need to check with the engineer who's responsible for the design of the building to make sure that any loads we consider or work out are representative for the building and for the region. These are some of the different codes we come across. Uniform Building Code is in America, Canada. International Building Codes is different New Zealand codes. So again, we work in all sorts of different regions, so we are familiar with different regional practices. We've also looked at loss prevention data sheets as well, in terms of how our system works. We do have structural design calculation sheets so we know how our system performs, how it functions. But it's also always important to note there that the structural engineer responsible for the project confirms that any of the calculated loads or assumed loads that we use or you use, they are correct and applicable for the project. Any questions? Okay. Want to go back over anything? I think that's it. End of the session. I'll just check though. What's coming next? Yeah, finish. Thank you. Thank you. Okay. Not bad time. Thanks for that, gents. Yeah. I can. We. I can send you that for this region. Yeah, I can send you. It depends what the building class is, but I can send you some information on that. Yeah. Have you got a card or?
You can give me yours, I will send you testimony.
Yeah, if you give me, yeah, there's my card there. If you just send me the question, and I can send you some information back. Is that okay?
Yes.
Okay, no problem. Thank you.
مش شو الفرق بينه وبين المشرف عشان كده
ديك اغلى من اللاين اكيد مش بكتير بس انه محل ما قادر تحط فيرنز اكيد الفيرنز
فعلا ارخص. ثاني شيء اذا اليوم بيروح ل 20 امام باكينج كثير كثير غالي. وانا سالت شو الفن بيروح للستيل ستراكشر مثل ليك ستايل ما بده قرش انا اذا اليوم انا اليوم حتى 10 مقابل حديد انا بحب الكلاين بقول له مش وين ها نحن وقت عملنا الباكينج كله كان الكلاين ما بيشوف شيء انا لو بدي شيء غير السيستم بدي اوفر الساعه كامله خلي اعمله كونتراكتر مع الثاني اعمله هاي بتقلل السيكونس صح قلل اذا بدك تركز واحد انا الرافتر كثير غالي اليوم انت بدنا تكتب الرافتر ما فيك تزيد انا لو بدي فعلا فيني استغنى عنها حط له لها بس كتل سبورت طبعا ايه طبعا بكثير يعني لكن في ندخلها رينفورسمنت بقلبها فيها فراغات ندخلها رينفورسمنت قبل يصير ركبه يصير بتساعد بالسبورت بضل ارخص ما اروح انا فنس حكون خفيف اذا الكلاينت ما بده يشوف الفيرنس الديزاين كثير عم بقول افضل الله اعمل سبان حسب ما انت شو بدك بس لا طبعا لازم بطل تفكير لا انا مرات بقلل ديك شيء هذه نحن بنسميها
let's go
Yeah, just like this
You like the system?
Yeah. Clicks, yeah, good. Say to our IT department, I want one. And they'll probably say no. Oop, that's still on there.
هو عمل نصه.
So it went okay.
Well done.
We can offer lots of support with any issues. Lots of experience with different regions as well. So we have a lot of design tools to make things simple, and we like a lot of information.
Your card?
Yeah.
I will send you my card by message because I don't have it.
Okay. Yeah. No problem.
Thanks.
Thank you. Cool. Let's go. That's good.
Another thing, don't allow them to install anything without job. You hold that filling, sure. Can you take can you take me a picture for this period site? Okay, this is one, and another thing, Saturday, stop him, don't allow him to install until you finish holding this piece. Okay, you put somebody fix the jack. After he puts it down, you fix the jack to the